Welcome to Cyber Tech and Risk Trusted Cloud Virtual Conference. We will start our conference with a keynote speech. We are honored to have Matthew Tim, Vice President, Cyber Technology Officer from Royal Bank of Canada to start this keynote talk. I'd like to do a quick introduction about Matthew. As VP, Matthew oversees the cyber strategy, cloud security, strategic partnership, innovation, and security architecture, engineering, and integration teams. A lot of responsibility. Matthew is responsible for a number of key aspects of RBC's cyber ecosystem, from establishing the strategic vision to defining cyber roadmap and implementing world-class cyber solutions for RBC globally. Matthew will comment on cloud security, a business enabler.
Thank you, Brian, for bringing together the security community in the cyber tech and risk industries to discuss cloud adoption and security. On behalf of RBC, it's a pleasure to partner with you today. So today we will hear from many speakers who will talk to cloud adoption, governance, risk and compliance considerations, data protection and privacy in cloud. The threat detection and multi-cloud management will be other topics that will be of great interest to everybody. And as we work to maintain continued confidence in cloud and computing, I'm sure that these topics will really help you build your own security programs. I'm confident you will take away many valuable learnings as you participate in the sessions and work with the industry colleagues. When I started thinking about the topic for today's talk, themes and messages, I wanted the audience to take away I was posed with either an entertaining or relevant talk. I decided that I wanted to share a few perspectives to make it a relevant talk for everyone so that we can change a few mindsets to think about security in the cloud that could be perceived as an enabler versus a roadblock. A well-secured environment is not just for show. It provides the business partners the platform to adopt these environments with assurance, meaning that it is secure, and that the infrastructure, code, and security controls are in place and working to protect the data that is important to the business. If adoption has less friction, it will be seen as an enabler and easy to use. In contrast, if it's not, it will be considered to be a roadblock. Don't get me wrong, none of what I'm talking about and about to share is easy to implement or deliver. A secure cloud environment requires significant investment, a strategic vision, a well-crafted plan, and delivery organization. And there has to be an integrated operating model to connect the right teams together at the right time, and finally the right skills to execute on the task at hand. And to reiterate, none of this is easy, but if done right, can yield great benefits to the growth and speed of cloud adoption and will be a real life business enabler. Let's take a quick look at the challenges related to cloud security. The growth of cloud adoption, business demand for speed of delivery, traditional security practices which are ill-equipped to deal with the complexities of securing cloud and applications, and it results in new risks that need to be managed. How many times have you heard about successful attacks due to misconfigurations and human error? These are not just stories. You can Google any of these topics and you will see lots of scenarios where environments have been compromised due to these weaknesses. It all starts with a well-defined strategy. How can you plot the course forward if you don't know what you want to achieve and what capabilities need to be in place over time to mature the security posture of the cloud environment? A comprehensive cloud security strategy is necessary to prioritize staffing and investment decisions for making the risks of cloud, to manage the risks of public cloud. Cloud adoption continues to grow rapidly, yet many traditional security functions are not well prepared to manage the shift. Risks get introduced where traditional security functions are ill-equipped because of the traditional security mindset, which is around hardware and the networking. And the shift to cloud requires the shift to the mindset of code. Requires a breakdown of risk management responsibilities as some of the responsibility for cloud initiatives and activities move to the cloud platform, data owners, cloud developers, and applications. There will be scenarios where security controls are implemented by development teams and not within security. So it should be known that with this distributed model comes added complexity, and this requires close attention. And now that we agree that the security strategy is an important and key element to creating business-enabled secure cloud environments, here are some key components of the strategy for consideration. A well-defined risk framework for public cloud. We will get into the risk later in this session. Defining a cloud security architecture for the public cloud is a key factor for success. Define proposed purpose-built security architectures to provide protection for public cloud services. These can be achieved by defining a cloud-specific control framework and security control objectives. Design your security architecture to encompass cloud-based workloads and underlying infrastructure. Implement the appropriate technologies and processes to put in place cloud controls that address the risks relevant to the cloud implementations. And establishing cloud security governance is key over cloud security activities by defining the responsibility model for cloud and cloud security services. Automation is an absolute foundational component. Wherever possible, implement security controls through automation, make it easier for cloud users to uphold their responsibilities. Securing cloud services. Cloud technologies present the potential to improve the security posture. Cloud platforms providers continue to engage in the race to offer better and easier to use security capabilities. There are purpose-built capabilities which should be used. The security teams have to assess these and determine for the best usage, but they will also have to leverage third-party technologies because some of these native capabilities are still in their infancy. Risk assessment and risk management, cornerstones of security. The assessment of the cloud platform and applications are important to formalize and to track risk. Risk treatment for identified risk and continuous risk monitoring are absolutely important. Building cloud security skills within the security team. There's a section dedicated to this later, but we'll cover a few key points here. The skill shortage facing information security teams will continue in the public cloud, and the race to acquire talent will continue to be hotly contested. A talent management program is necessary to acquire enhanced and to develop these cloud security skills will require a lot of attention and investment. Sourcing talent from non-traditional places like IT and using an array of development approaches to keep skills up to snuff and current will be important. Identify and prioritize the key competencies to target development plans to keep pace with evolving technologies in cloud. Securing data in public cloud. Another cornerstone of securing cloud is the protection of data. If this is not done right, the rest may not be relevant. Consider economies of scale. Build once and reuse many. Strive for ease of adoption as part of the developer pipeline to integrate security versus bolted in at the end. Build confidence with the business that their client's data is secure in the cloud platforms through assurance. And how do you know that the security is working? The only way is to test it continuously. This is not a small task, I might add. They're critical to enabling the business value. I mentioned during the introduction that we'll be going through the cloud risks in a little bit more detail. So there will be a few here that we will start with for discussion. Start with the framework of applicable cloud risks. Leverage industry frameworks such as the Cloud Security Alliance and augment it with risks relevant to the organization. And these will be sourced through specific regulations, industry standards or incidents, or even incidents that have occurred through other organizations that have been victims of breaches or attacks. There are no shortage of these. Building this framework will help identify the range of cloud risks and criticality of the assets that need to be protected, what policies, standards, and controls are needed to mitigate these risks. Let's go through these risks in a bit more detail. Root cause analysis and preventative measures that can be taken. Publicly exposed data instances. We've seen those before. Inexperienced developers make errors during configuration and coding. You could leverage the preventative actions could be leveraging native capabilities or third-party tools to automatically correct these misconfigurations. Cloud-based denial of service attacks. Malicious actors can bombard internet-facing applications with service requests threatening the availability of cloud services. Use rate limiting, elastic load balancers, and other native tools to protect against these denial of service attacks. Weak access credentials. Weak passwords used when setting up identities in cloud services. set access credential strength requirements, and automate enforcement of multi-factor authentication mechanisms or rotating of access keys as examples. Poor key management. Multi-step key management processes become onerous for security teams to manage as the number of keys increase. Centralize the key management and automate the third-party key automate with third-party key management tools where possible. We've all heard about insecure APIs. This is where development teams could use open source or potentially insecure APIs to connect applications without assessing the risk first. API identification and API security become important security controls to implement. And we've all heard about malicious insiders. These are both within the organization as well as in the cloud security provider. The only ways to really ensure data doesn't get accessed in an authorized manner is to protect it at rest and in transit through encryption. And then finally, it is about prioritizing risk mitigation. Determine the most significant risks to your organization and the cloud's use cases, and align preventative measures with these risks. The prioritization should consider the errors developers commit in specific cloud environments, the maturity of a cloud security provider's capabilities for implementing controls, and the prevalence of these risks across cloud deployments. Defining the right controls are important. Let's talk about a few of the key steps here and some of the controls that we should be all considering. Limit cloud misconfiguration errors through locking down S3 buckets, as an example. These are often misconfigured to allow public access and result in information disclosure. Publish policy standards and implement these controls for cloud configuration settings, and use automation to correct errors. This can be achieved through native or through vendor options. Secure application containers. Vulnerability scan all your open source or insecure Docker images that are used by development teams. Create an authorized set of images and conduct process isolation, apply least privilege rights, and include the removal of root user privileges in all containers. Virtual machine integrity through the certification of golden images, and harden these according to security specification. Maintain virtual images through hardening, vulnerability scanning, and using automated tools to ensure policies are applied across cloud deployments. Scan applications for vulnerabilities in code and for data-specific risks, such as sensitive data and malware. Identity becomes key, and we've all learned the hard way with insecure identity protection, and to reduce the threat surface through protecting these identities. Establish configuration standards for network, storage, compute, and platform services. And leverage third-party tools like Cloud Security Posture Management for workload protection. There are an array of capabilities that these services can provide. The security team will have to do lots of research and to define the set of controls that they would like to leverage from these tool sets. They could also use native cloud monitoring for visibility of cloud service or cloud activities, and adopt formalized response playbooks to respond to things like configuration drift. Response is key as well, building out security response scripts to respond to anomalous events and unusual behaviors that are indicative of attack or breach. And finally, we should always look at testing our controls through penetration testing and red and purple team exercises. We have found through testing a number of weaknesses that could be easily compromised through hackers or through malicious users. Using these techniques, we're able to identify gaps and we could remediate them very quickly. Cloud security standards or control objectives are needed to underpin these control sets. Example would be to define control standards, require encryption, for example, on high sensitivity data at rest and in transit. Many standards will be common across multiple service providers for a given deployment model, but the technical means of meeting them will be different. And that has relevance and bearing on the skills that are needed in order to secure each of the platforms. And we'll go through that a little later. Finally, with defining standards and control objectives, the security teams will also need to be able to provide guidance and advisory to make implementation easier for developers. Often there's an interpretation of a sort, but it has to be validated by the security team. To enhance security monitoring, you have to assess the future of cloud platform adoption. So all these controls require some form of monitoring and a pane of glass in order to determine, and eyes on glass in order to determine that the controls are working, or if an issue has arisen and someone needs to take action to close it down. Single platform versus multi-platform makes a difference. The multi-platform path can add complexity for security teams. And in a multi-cloud world, security has to decide on whether to use tools that standardize controls across multiple providers or leverage cloud-specific native capabilities that can offer value on a point-by-point basis. The goal is to create a single pane of glass. We've all heard that for implementing multi-cloud, and apply these controls where it makes sense while leveraging native tools which could meet better control requirements within that platform. I think single pane of glass has proven to be a bit more challenging than it's made out to be. I don't think that there are technology capabilities that provide full coverage across all multi-cloud environments, and those are things that the security teams will have to look at and determine what's going to be what will work for them best. Then use abstraction tools potentially for controls operating more seamlessly across multiple environments. We're yet to see a tool that works across 3 or 4 cloud environments, but maybe you could standardize on a tool set for 2 or 3, and then some of the native tools for those that don't have coverage from these abstraction tools. The shared responsibility model. With cloud, that shared responsibility model at the onset wasn't clearly understood, but as experience has been gained, that has become better clear and more clear to us. And obviously through roles and responsibilities definition has enhanced our operating environment. Various models exist to achieve this shared responsibility model. And here are a few examples to get you all thinking. Consider that this does provide one-size-fits-all model, but will likely end up being more hybrid. You could centralize the security development for reusable security services. This allows the maintaining of quality control that secure services as they're adopted. Ideally, these would be part of the development control plane and is mandatory versus optional. These could be in the form of preventative or detective controls. Where security is decentralized to development teams, security standards need to be defined for developers, and security teams need to provide more guidance on security. Security should track and share best practices across these development teams to harmonize security controls implementation and ensure that all delivery teams benefit from improvements made by the individual teams. They have to establish roles and responsibilities for sharing public cloud patterns and services. Establishing these RACIs for cloud services provides clarity for security operations teams, development and project teams on cloud security activities that each are responsible for, and gives transparency to functions such as audit, where they fit into the cloud risk management process. With the model of developers accepting more responsibility for implementing and maintaining security controls, security teams will need to focus on consulting to business and IT on the risks of new cloud services, setting policies and standards, distilling technical guidance for meeting those requirements, and monitoring compliance. We talked about automation earlier, but these are a few more automation value statements that could add value to your business cases. Leverage automation to minimize the burden of controls that developers have to implement. The growth of the cloud security ecosystem will require automation to scale, and with the greater adoption of business cloud use. Automating cloud security provides the benefit of ensuring security controls are implemented while making cloud deployments easier for developers. To implement security automation, first, identify security gaps the automation should fill. Develop familiarity with the relevant cloud native tools, and consider leveraging vendor tools like cloud workload protection platforms. Start by identifying the best use cases for security automation, and the security team should strive to implement an automated tools model for common and risky behaviors. Developers, to mitigate risky behaviors, developers could exercise while they're committing their code into cloud workflows. while using caution not to override these controls. Monitor cloud compliance and apply security monitoring capabilities. This is through the cloud security provider or through the vendors, and how they each offer different options to monitor user behavior and activities that are happening within the cloud platform. Cloud security access brokers have expanded to enable security monitoring in IaaS environments as well as SaaS. These are purpose-built and have definitely a place. Cloud workload protection platforms can provide visibility and protection for capabilities such as configuration management, data security, and data flow analysis. We also have to gauge the development team's maturity to prioritize monitoring efforts. Assess the maturity of development teams to gain a better understanding of where security teams will need to conduct more extensive monitoring and potentially provide greater implementation support. As the maturity practices evolve and improve, then we can allow more mature teams to have greater flexibility in implementing controls, which can generate new best practices and lighten the load on the security team. Security compliance and monitoring. This is a case where adherence to controls are important, so we can understand the state of the security posture and within the platform. Control assurance is about control design, control operations, and continuous testing. These become very important to ensure that we can demonstrate that controls are working as designed and that there's a testing methodology to go through that rigor of testing the controls. When you look at the key controls within a cloud platform, these can become very extensive. So some of the guidance would be to really focus on the key controls, and not every control would be key. And then also to look at the end-to-end control testing elements of that program. I can say that you will definitely find lots of challenges and roadblocks along the way, because a lot of the controls that you're going to test won't be within the control of the security platform, or the security, even within the platform itself. Some of the controls will be with the data owners, within the data pipeline, and also within things like how data is classified, how data moves, and then how does data land? And then when data moves within the platform, how do you know that the data isn't moving outside of your controlled environment? This security and compliance monitoring will become even more important with the regulatory scrutiny that some of the organizations that are participating here today are under every day. That regulatory scrutiny becomes very intrusive, and those controls have to be very solid and actually well designed and comprehensive in order to demonstrate to the regulatory bodies that the organization has a handle on the control framework and the control sets. Moving on to cloud security skills. It all boils down to cloud workforce planning. We touched on this earlier, though now we have to dive deeper into some of the key areas of cloud talent management. Effective workforce planning for cloud security is contingent on defining the skill sets needed to secure cloud services and cloud platforms. Depending on which platforms and how many organizations plan to leverage will define the broader skill sets and talent management strategy that need to be employed. Keep in mind that major platforms require unique skills for each. Azure, AWS, Google, these are the main platforms. All of these require skill sets within each in order to, let's say, fully secure each platform. There are also varying types of roles within each platform. For example, engineering, architecture, development, operations, security monitoring, vulnerability management. And all these have to have supporting processes. The controls themselves don't just exist on their own. And when you layer on the testing, then you'll have to have a testing methodology as well as the skills in order to test each of these controls within each of these platforms, which definitely require a skill sets approach to building talent across a multi-cloud environment. Additional examples are in IaaS, where new skills are required to develop automation scripts to apply security rules across infrastructure as code environments. And that was the point I was making about traditional versus cloud mindset, which is cloud is definitely more code centric, and the traditional is really focused on platforms and infrastructure security. PaaS requires security staff to be able to provision APIs and other embedded security features to fit security into the continuous delivery pipeline. That is the point I was making about the integrated model, where no longer can the security team sit outside of the development teams. They have to be fully integrated so that the security controls get built as the development process evolves, and actually the pipeline gets delivers the controls. There's no use in trying to bolt in those security controls at the end. And then align the security skills development with the cloud priorities and key risks facing your organization, and the controls needed to mitigate them to maximize the return on investment. Look outside the box when looking for cloud security talent. Cloud is a journey, and there are lots of learnings along the way. Security teams will also learn and develop cloud skills as they get more practice and more experience with each of the cloud platforms. It's a team effort, and security can't manage cloud risks on their own. Build a foundational set of cloud security skills to establish the cloud security function. Got to look at cloud to IT for key talent which can be developed for security. Acquire key talent, and that may be external. And that may be the start of building the cloud security practice and across each of the platforms being leveraged to deliver cloud security solutions. Often the resources have either delivered solutions before or are employed by cloud providers. This is key talent that's going to be important to try and acquire in order to establish the baseline of the skills that are needed. Build a talent management pipeline, which have a combination of gained experience, certifications, learned advanced skill sets, training in specific cloud disciplines across architecture, engineering, and development. Through the development of recruitment, build skill sets to meet the highest value skills needed, first to ensure security can keep up with the business cloud adoption. And leverage novel approaches like building skills through experimentation and learning through doing. These could be done through special projects, isolated testing environments to build up knowledge and understanding of how security works in cloud environments. Devise a variety of development strategies, such as talent sharing programs to build a cross-functional knowledge base among security staff. Stage collaborative exercises to drive learning within security and technology teams. Efficiency and cost management. A major business benefit enabler is if you can show the cost efficiency and cost management to the business. With the start of any security program, there is a cost to invest. So that cost will obviously have a growth component within a few years. But over time, through automation and reuse of the controls, that cost model should start to flatten out and eventually go down over time. That is a huge benefit to the business. So that mindset of create once, use many, and then through the automation of tooling, through code as a service, those are absolutely going to be key to enabling the business through this cost management model. In conclusion, let's recap on the key themes. Embracing public cloud has the potential to provide enhanced security protection if done correctly. Cloud providers are providing more native security features, so it's up to the security team to figure out how to leverage these most effectively. Third-party security technologies have a role to play, and these need to be figured out for best fit, especially those tools that are used for abstraction layers and for potentially a single pane of glass across multi-platform environments. Cloud requires cybersecurity teams to think about cloud security in new ways. This includes learning and adopting new practices for managing the people, process, and technology that go into securing public cloud. Cloud is here to stay, and the business adoption will grow. So the easier to adopt security, the quicker the security platforms and services will be used by the business. Again, that is that theme about enabling the business. And don't forget efficiency and cost management. If you can get the costs down, that is a huge benefit to the business. Design secure cloud environments to provide automation, reusability, economies of scale. Strong data protection will be seen as well as business enablers. So remember that strong data protection is about protecting the data that is most sensitive and most important to the business. Without that, I would say a lot of the other controls don't matter. Really focus on data protection and ensuring the security of that. And then with the testing program, it can be used to provide assurance that the controls are working as designed. It's a race to the finish line, so the first to market usually will have a better chance of succeeding. The business enabler is about time to market. It is about enabling the business to get to market quicker, to adopt the platforms and add value to their clients. That is the tenet of success for them. Let the business see the secured in cloud environment as an enabler, not a roadblock. So the whole theme about this session is about enablement and not about putting security for the sake of it or letting security be a roadblock. Finally, before I sign off, I just wanted to do a quick shout out to Ava, who helped me with the slide visualization. Great job, and thank you very much. I'd like to thank you all for attending today, and I'd like you to encourage you to attend all the sessions and to enjoy the conference. Thank you all very much.